Welcome back to the workshop. We want to continue taking a look at section 4.2, paths and circuits. And in this video, what we're going to do is we're going to take a look at circuits and cycles, actually. So let's take a look at our notes. We'll start off with what exactly we're taking a look at. A cycle is a path V1, E1, V2, E2, and so on, right? Like a path. It's a sequence of vertices and edges, where the edges connect the vertices, of course. Okay, so a cycle is a path. Excellent. But the key here is that the first vertex and the last vertex are actually the same vertex. Okay, so we have the same initial vertex and the same terminal vertex. So those are both actually are terms used for just a path in general. The initial vertex is the first vertex, terminal vertex is the last vertex. So in the case of a cycle, the initial vertex and terminal vertex are the same vertex. All right. Beyond that, all of the vertices and all of the edges in a cycle are distinct. Okay, so we're not repeating any edges and we are not repeating any vertices. So this is a cycle. A cycle is much like a simple path, no repeated edges, no repeated vertices. The only difference is the first vertex and the last vertex are the same. Okay, so V1 to Vn are distinct, E1 to En are distinct, but V1 and Vn plus 1 are the same. Okay, if we have the same initial and same terminal vertex, but we don't have that all of the vertices and edges are distinct, we actually have what's called a circuit. So a circuit begins and ends at the same vertex, but may repeat vertices or edges. Excellent. So let's take a look at an example here. We want to identify several circuits, much like we did in our previous example, but we want to do this in a way where we are creating a cycle that does not repeat any edges or vertices, repeat an edge, and then repeat a vertex, but not an edge. Again, similar to what we did in our previous example. All right, so let's start off with a cycle. Let's not repeat any edges or vertices. This is a mess of lines. And so it might take a while for us to look at this and find a cycle, find something that does not repeat a vertex or an edge. But I would encourage you to feel free to pause this video and try to do each of these things for yourself. The answers you come up with might be different than mine, and that's okay. But feel free to do that. All right, if we wanted to find a circuit that is a cycle, then, for example, I found that we could go from A to H, and then from H to E, and then from E to K, and then from K, we can actually connect ourselves all the way back to A. Excellent. So since we do not have a multigraph here, or we rather have what satisfies the definition of a graph, I can again give paths as a sequence of the vertices that are visited. Excellent. So let's find a circuit that repeats an edge. Again, you could try this for yourself, and what you find may be different than what I find, and that's okay. There are more than one. There is more than one. There are several examples of circuits in this graph. Okay, so let's find one that repeats an edge. I chose one that starts at B. From B, it moves to G. From G, it goes to D. From D, it goes to K. From K, it goes to F. From F, it goes to G. Long travel back to G. And then it goes to B. So I actually just made a cycle in G, F, K, D, G, but then added GB in there as a starting and ending. So I repeated the first and last vertex, or sorry, the first and last edge are actually the same here. So we have that it repeats an edge. We go from B to G, and then to D, to K, to F, back to G, and finally back to B. Excellent. So that repeats an edge. If you wanted to, you could note here the edge from B to G and the edge from G to B is the same edge. All right, so let's find a cycle or a circuit that repeats a vertex but not an edge. And there again are several examples, so I would encourage you to try to find one for yourself if you have not already, and maybe you find the same one, maybe you find a different one. All right, so let's go with, all right, I've got a couple of options here that I have found. So let's start at vertex B. So starting at vertex B, I can move to K. Now remember here, in order for me to begin and end at the same place and pass through a vertex more than once, that vertex has to have a degree at least 4, because I've got to come in and out on different edges, and then come in and out again on different edges that are different from the first ones. So that's 4 edges that I have to travel on that are connected to this one vertex. So I've got to pass through K here because everything else has degree less than 4. So K has to be involved in some way. All right, so I've got from B to K. Let's go from K to E. K to E. From E to J. Oops. E to J. From J to C. Lots going on here, lots of color. Hopefully you can follow what's going on there. C back to K, right? K is the one that we're going to have to repeat because it's the only one with 4, with degree 4 edges adjacent or incident to it. Up to K, K-E, K. Looks like I wrote something down wrong. I got to go to F here, it looks like. Then I can go from F to G, and then from G to B. Excellent. That one works. It's a bit of a mess. Let's see if we can follow it back again so we can write it down. All right, so we started at B, then we went to K. With it drawn out here, the exact way in which I travel it doesn't really matter, but I believe we went from B to K, and then to E, J, and C. K, E, J, and C. E, J, C. Back to K, then F, G, B. Back to K, then F, then G, and finally back to B. So you should see here that we repeat a vertex, vertex K, but no other vertices repeat, and hence no edges are repeated. Okay. Let's see. Yep. Okay. Looks good. All right. That's all that I wanted to share for this video. The next definition will actually start off our next video with. So thank you for your time. I'll see you guys back in the workshop very shortly.